measures of dispersion. We all know that measure of central tendency gives one of the very important characteristics of data. Central tendency computation should be based on all observations. But do we all know what measure of dispersion really is? A measure of dispersion describes the spread or scattering of the individual values around the central values. In this lesson, we will discuss dispersion and measure of dispersion, also range and standard deviation. After going through this presentation, you should be able to define dispersion, explain the measures of dispersion, and understand the concept of range, interquartile range, and explain the term of standard deviation. The concept of dispersion is related to the extent of scatter or variability in observations. Dispersion is a synonym for variability and it indicates how close data are clustered about a measure of central tendency. Now the question arises, why measuring dispersion? Measuring dispersion provides test reliability of an average to facilitate the computations of other statistical measures. It also serves as the basis for control of variations. Various measure of dispersion is range, interquartile range, and standard deviation. The range of a distribution is the difference between its two extreme observations, that is, the difference between the largest and the smallest observation. For calculation, first find largest and smallest number in data set, then subtract smallest number from largest number. The difference is equals to range. Coefficient of range can be calculated by adding the largest and smallest observations and divided by difference between the largest and smallest observations. Coefficient of range is also known as coefficient of dispersion. In this example, for consultant X, 37 minutes is the highest value and 3 minutes is the smallest value. Range can be calculated by subtracting the small value from high value. Then range is equal to 37 minus 3, which equals to 34 minutes. For consultant Y, 13 minutes is the highest value and 9 minutes is the smallest value. Range can be calculated by subtracting the small value from high value. Then range equals to 13 minus 9, which equals to 4 minutes. Interquartile range is an absolute measure of dispersion given by the difference between the third quartile and the first quartile. It is not sensitive to extreme values in a data set and to the sample size. For calculation, first put the values in order from low to high and then divide the set of values into quarters, 1/4. Then for the values in the middle 50%, subtract the lower value from the higher value. For example, 16 salespeople were given 12 problems associated with on-the-road sales. For keeping automobile expenses, the rankings follow: 1, 1, 1, 2, 3, 4, 5, 6, 7, 8, 8, 9, 10, 11, 11, 12. For calculation of interquartile, first divide set into quarters. Blue colors is the first quarter. Red colors is the second quarter. Yellow is third and black is fourth. Then calculate the mean of last value of Q1 and first value of Q2. That is, 2 plus 3 divided by 2 equals to 2.5. The mean of last value of Q2 and first value of Q3. That is, 6 plus 7 divided by 2 equals to 6.5. The mean of last value of Q3 and the first value of Q4. That is, 9 plus 10 divided by 2 equals 9.5. Then range equals to 12 minus 1 equals to 11 because 12 highest value and 1 is the smallest value. Then interquartile range equals to 9.5 third quartile minus 2.5 first quartile, which equals to 7. It means that 50% of respondents lie within the 7th rank order points of each other. Standard deviation is denoted by the Greek letter sigma, which is called small sigma or simply sigma. It is the average of distances of observed values from the mean value for a set of data. The mean absolute deviation, MAD, is the mean absolute deviation from the mean or median. For calculation, first calculate the arithmetic mean, AM, then subtract each individual value from the AM, square each value, multiply it times itself, sum total the squared values, divide the total by the number of values n, and calculate the square root of the value. In this example, observations are given. First, calculate the arithmetic mean AM, which equals to 14. Then subtract each individual value from the 14 AM, square each value, multiply it times itself, sum total the squared values, which equals to 1403. Divide the total by the number of values, n equals to 10, which equals to 140.3, and calculate the square root of the value, which equals to 11.8. Distribution curves are shown in these figures. First standard deviation will lie between -1 to +1, and the area it covers is equal to 68%. Second standard deviation will lie between -2 to +2, and the area it covers equals to 95%. Third standard deviation will lie between -3 to +3, and the area it covers equals to 99.7%. Now let us check if we have understood the various concepts discussed in this lesson clearly. In a more dispersed set of data, standard deviation is greater. Right or wrong? Right. Variance is square root of standard deviation. Right or wrong? Wrong. Variance indicates the average distance of any observation in the data from the mean. Right or wrong? Right. Before we end, let us briefly revise what we have studied till so far. Average deviation is the arithmetic mean of the absolute deviation from the mean or the median. Coefficient of variation is a ratio of standard deviation to mean expressed as percentage. Interquartile range considers the spread in the middle 50% of the data. The quartile deviation is 1/2 the distance between first and third quartile. The range is different between the largest value and the smallest value in a set of data. The standard deviation is the root mean square deviation of a given set of data.